Hello, welcome back to another one of the A-Level Maths live streams. So we're finally starting the A2 content, and we're going to start off with functions, which is a huge part of the A-Level specification. It's going to bring together exponentials, logarithms, and graphs, transformations, and everything all into one nice little package. And it does kind of follow on from where it is in GCSE, but of course you have the more advanced functions, and you also have to talk more about the domain and ranges of functions, which is slightly more tricky, but with some examples that we're going to do, we'll get right through it. So first of all, it says the functions f and g are defined by f of x is 3x plus 4, and g of x is 2 over x plus 3. So the first thing we should look at is, if you notice, and you would have seen this on your GCSE exams too, but you might not have known what it means. This right here is something called the domain. And the domain is just all of the x values that we can have. So all of the possible x, which also you can call it as the input values, right? So what that means is, what values can I put into this function, right, that are legitimate, they don't give me an invalid result. And if you notice, it has this symbol here, and then r. So what this actually means, this part here, is it's the set of all real numbers. And if you remember, a real number is literally just any number from minus infinity to plus infinity. It can be an integer, it can be a decimal, it can be anything, okay? Technically that should have an s on the end, okay? So that should make sense, right? If I look at what x here, is there any value of x that would give me a naughty number, right? Something that would be unsolvable, math error. No, right? Like, I can put in negative infinity, plus infinity, and every single number in between and get a valid output value. So the range of values is infinite as well, okay? And if you look at for g of x, we have x is any real number. It's the set of all real numbers except 3. And if you look here, if I subbed in 3 here, technically this should actually be minus 3 for this question. But if I sub in minus 3 here, I would get minus 3 plus 3 is 0. 2 divided by 0 is a math error. So that is where we get these from. Part A, it says evaluate fg of 1. So again, this is a bit of a recap from GCSE, but essentially you work from the inside out. So if you work out what g of 1 is first, so that's just 2 over 1 plus 3. So 2 over 1 plus 3 is 2 over 4, which is 1 over 2. Okay, and then all you need to do is sub whatever that value is back into f of x. So 3 times a half plus 4, which is 3 over 2 plus 4. That'll be 8 over 2, so it should be 11 over 2 overall. Okay, nice and easy. For part B, it then says solve the equation of gf of x is equal to 6. So this is slightly more involved. What we need to do is work out what the equation is for gf of x. So what this means is I take all of the function for f, the entire thing, and I substitute it in place of x in this expression here. Okay? So if I write that out now, we have 2 over, and instead of x, I'm now writing 3x plus 4. And then plus 3 again on the end, which is of course equal to 2 over 3x plus 7. And now in the question it says we need to solve for when this whole expression equals 6. So I'm going to equate that to 6, and now it's just a simple linear equation that we need to solve. Okay, so again, when you have gf of x, you're substituting in the second function into the outer function, the first function, okay? So I'm going to times both sides by 3x plus 7. And we have 2 is equal to 6, 3x plus 7. I'm going to take it nice and slow just to make sure we don't make any mistakes. 6 times 3 is 18. Add the x on. 6 times 7 is 44. Sorry, 42, not 44. What am I talking about? 42. And subtract 42 from both sides, so let's write that out. We get negative 40 equals 18x. So x is just equal to 40 over 18. And of course that's a negative. So negative 40 over 18, so you can keep halving it if you wanted to, or you can use a calculator to work it out because A-level exams are all calculator. So let me just open up the calculator so we have it ready. Yeah. So negative 40 over 18, again, minus 20 over 9. So yeah, you can either half it or you can use the calculator. So minus 20 over 9. Perfect, and that'll be it. So 6 marks, it's relatively quick, not too bad, I like to think anyway. Question 2. If we have a look, the function f is defined by this quadratic, and once again, we have x is a set of any real number, but it has to be greater than or equal to negative 1. Now sometimes you might look at this and think, why is that the case? Sometimes they just place the restrictions themselves. So they'll restrict what values you can have for x intentionally. But we have a new word here, the range. So what is the range? Well, the range is all of the output values. Put values. So if I put in any of these domain numbers, what is the range of values I can get out of the end, right? So if I sub in minus 1, then 0, and then 1, etc., or the set of all the values. Now, with a quadratic, it's actually very difficult to see what that is just by looking at it, right? Because it's saying x has to be greater than or equal to negative 1, so you can probably work it out by just subbing in negative 1 and then working out from there. But that doesn't work always. So I'm going to show you the way on how it works always. So again, in this case, they make it slightly easier by showing you this, okay? However, if you imagine that isn't there, here's what you would do. You would do completing the square or factorization in order to work it out. So you'd always do factorization, completing the square. And the reason for this is that completing the square gives you the minimum point of a function, a quadratic function. So that would be x plus 1 squared minus 1 squared and then plus 1 on the end. So we just get x plus 1 squared. So my minimum point is at minus 1, 0. So what are the range of values that I can get? Well, this is the smallest y value. Right, that's the smallest output value I can get, which means f of x has to always be greater than or equal to 0, because it can only get bigger, because the smallest value is 0. So again, you could have seen that just by subbing this into this equation here. However, you don't always get given that. Okay, sometimes they'll just give you a quadratic and they won't give you this part, and you need to state the range. Best thing to do is just find the minimum point. How do you find the minimum point? You do completing the square. You may notice that, in fact, in this question specifically, you could have just done regular factorization, but yeah. Part B. It says you need to sketch the graphs of f of x and f minus 1 of x on the same diagram. So let's have a look-see. So I'm going to sketch f of x first, which is x plus 1 squared, and it crosses the x-axis just once at minus 1. So you'd have a graph that looks, I mean, to be fair, I probably just want to do something that goes like this. Okay. And it should also cross y, so if I sub in x equals 0 to get the y-intercept, it'll cross there at 1. Now, what is the inverse function and what does it look like on a diagram? Well, the inverse function is the function that will give us the exact opposite of this. So in this question here, in this initial equation, I put in x values and I get out y values. The inverse function is if I put in the y values, I should be able to get the x values out. So it's the function that does the exact opposite of an initial function. And it turns out that that is just a reflection. So f minus 1 is just a reflection in the y equals x line. So this means the coordinates swap place. So what I mean by that is, and they swap place and sign. So what I mean by that, for example, here the x coordinate is, so we have minus 1, 0. So now we swap those around, we get 0, minus 1. Because all I've done is I've taken the values and I've swapped them around. Here we have 0, 1. So what we're going to have is 1, 0. Okay. Now, if we actually look at this as being a reflection, it should look something like that. So again, all you're doing is reflecting the shape in the y equals x line. So you draw the exact kind of opposite if you can. But the way you can help yourself, and keep in mind that in the exam you will have to actually do this yourself as well, is you need to actually swap the coordinate places. So again, 0 moves to where the -1 is, the -1 moves to the 0 to make this. Okay, so you're basically just swapping it around. Okay, and you do that for every set of coordinates. So the minimum point, the x and y intercepts. Okay, perfect. Well, technically there's only ever one y intercept, but we'll get onto that a bit later. So for part C, it says find an expression for f minus 1 of x and state its domain. So here's what I do. First of all, I write the equation out again, but instead of f of x, I'm going to write y. Now the whole goal here is to rearrange for x. Okay. So I need to get x equals something. So the first thing I'm going to do is I'm going to use that completing the square form because that's really convenient for me. Right? X plus 1 squared, and that is the same thing. So if I want to rearrange for x, I'm going to now square root both sides. So now I get square root y equals x plus 1 minus 1 from both sides, and I now have x is equal to square root y minus 1. And then I replace x with f minus 1 of x and y with x. Okay, so this is actually a relatively simple equation they've given me, but it's still 4 marks, so it's pretty beefy. But it can be kind of tricky to rearrange these because rearranging quadratics isn't something you may have done before because it is a bit of an obscure thing. But as you practice, you'll get kind of better at this. But you have to do this with things like logarithms and exponentials. So my inverse function looks exactly like, I forgot about that, x minus 1. And it asks me, what's the domain? So what values can I have? Well, again, what you could do is say, well, logically speaking, I can't square root a negative number. So x must be greater than or equal to 0. And you would be right. But, give me a second. That isn't good enough, okay? Because it may work in some situations, but it doesn't work in all situations. So what I prefer to do is use that logic I just did to check my answer. So if I get an answer and I apply the logic and I think, okay, does that make sense? And it does, then I'm good. If it doesn't make sense, then I need to have a look again at my method. Here's what you need to know, right? If you have a domain and range of the original function, they swap places for inverse functions. So for the inverse function, the domain equals the range of function, so of the original function. So if I have a look back at my range here, I said f of x is greater than or equal to 0. The domain of the inverse is greater than or equal to 0. It's the same thing. And likewise, the range is just the domain of the function. So what would the range be of this? Well, the range would be any real number, but it has to be greater than or equal to -1. So I could just write that as f of x is greater than or equal to -1. Okay? So hopefully that makes sense. But again, the domain and range just swap places, and that should hopefully make sense, right? Because I said that the original function takes x and gives you y, the inverse function takes y and gives you x. So those should swap around. Okay, so let's go on to the next one. The function f is defined by this expression where x greater than 0.5. Hopefully this makes sense because you can't take the log of a negative number and you also can't take the log of 0. So That should hopefully make sense. Part A, find the value of f of 1. So I would find f of 1 initially. So that is, and it says the exact value because it's a logarithm, right? So we have 2, 1, minus 1. So that just gives me 2 ln, plus ln 1. Okay. Now ln 1, you should hopefully know, is just equal to 0. So this is equals 2. And then I'm going to do the same thing again. So I'm going to take this result and plug it back into the original expression. And that will give me 2 plus ln 2 times 2 minus 1. So that gives me 2 plus ln 3, which is my final answer for 2 marks. So again, these function questions, they generally ask you just as a substitution, and they're generally going to ask you about the domain and range and inverse functions. So any one of those combinations. So if you can do that for as many functions as humanly possible. So what I'd actually recommend is, even for the questions that don't give us domain and range as a question, just as practice for your revision, just write it out anyway. So now finding the expression for the inverse function, again, my method is first to just rewrite the original, but with y instead of f of x. And now I'm going to try and rearrange for x. So with logarithms, it's actually not as bad as it may look. What you want to do is get rid of everything next to the logarithm. So if it's multiplying, adding, subtracting, whatever. So I'm going to minus 2 from both sides. And we get y minus 2 equals ln 2x minus 1. The next thing you want to do is something called exponentiating. So you're raising everything up to the power of e. So we have e to the y minus 2. And the cool thing about that is it actually just gets rid of the natural logarithm. So we're just left with 2x minus 1. So now we can just keep moving it over. And we get, so plus 1. So we get e to the y minus 2 plus 1 equals 2x. So then x is just equal to, and you can write this in kind of any way you'd like, but this is probably the best way to do it. Like that. So my inverse function now is just f minus 1 of x equals e, and this is where you need to be really careful, is you need to replace the y with x as well. So some people leave it as y, which does deduct your marks, unfortunately, but that would be your final answer. So again, not too shabby, I don't think. 3 marks, nice and quick, I'd say. Perfect. So for the next one, the functions f and g are defined by f of x is just e to the x. Nice. And x can be any real number, which makes sense, right? You can put any number in for the power of e. And g of x is 2x plus ln x. X has to be positive. Why? Well, again, you can't take the log of 0 or a negative number. So write down the range of f. So if I think this is just the e to the x graph, are there any values that it can't take? Well, a good thing to do is to sketch it, because, I mean, and this is literally why people sketch graphs in the first place, because it helps you visualize exactly what's happening. If I sketch the e to the x graph, I get something along the lines of this. And this, it shoots off to infinity. But if I notice, it will get infinitely close to the x-axis, but never below it, because this is asymptotic. So what am I trying to say? Well, it's always greater than 0. And that's exactly what the range is. F of x is greater than 0. Because again, if I were to draw the graph, the line, or the curve in this case, never crosses or even touches the x-axis. So that means the y value always has to be at least a bit positive. Perfect. For part B, it says find an expression for the composite function gf of x. So what does that mean? Well, we're subbing all of f of x into g of x. So let's do that. So gf of x is just going to be, so instead of x, I'm going to write e to the x, ln e to the x. And what happens when you take the natural log of an exponential? It gets rid of it. So these two things basically cancel each other out. But you still get left with the x. So you have 2e to the x plus x for that question. And then it says write down the range of gf of x. Well, this is where things get a bit more interesting. If I think about this value, this kind of graph here, it's pretty hard to draw, I will say. But if you notice, as this gets, and this is where you need to start using your logic, right? So as x increases, right, gf of x is just going to keep increasing forever, right? Because they kind of agree with each other, if you'd like. And it's going to exponentially get higher. So we know that gf of x can be positive. Can it be 0? Yes, it can. Why? Because this x can be negative, right? Now this can only ever be positive, but it gets smaller and smaller and smaller and smaller as you put negative values in, whereas this is just going to stay getting bigger and bigger and bigger when you put negative values. So if I put in minus infinity, for example, this thing gets really close to 0, and this thing gets negatively infinitely big. So essentially, gf of x can take any number. So how do you write that? Well, all you do is you put this e-looking thing, and you say that just means it's the set of any real numbers. And the r, you generally like make it look a bit fancy because it's not, you know, just r. The other way you can write it is some people prefer to do a double r like this, and that also works as well. Okay? I hope that makes sense. So, for this one, the function f of x is defined by, function f is defined by 1 over x plus 2, and of course x can't equal negative 2 because otherwise naughty things happen, we get a math error. Write down the range of f of x. So, this shouldn't be too bad. First of all, if I make x really close to 0, it can just be kind of a half. If I make it negative, it can be any negative number. If I make it positive, it can be any positive number. So basically, and I can also make it really, really small. So f of x can be any real number. However, there is one number it can't be, ever. Think about it. When you're dividing numbers, what's the only number you can never actually get as an answer? Well, you can never ever get 0. You can't get 0 by dividing. It's impossible. So that is the only value that f of x cannot take. Cool. So that was, I think, quite nice and easy. Now, if you like, if you look here, find an expression for f of minus 1 of x and state its domain. Well, its domain immediately is just going to be x doesn't equal to 0, but x can be any real number. That's the domain, right? Why? Because the domain of the inverse is just the range of the regular, and vice versa. So the domain of the inverse is just the range of the original value here. So I can write that straight away, get a mark, and I haven't done anything yet. But let's get down to business. So we have y is equal to 1 over x plus 2, and we need to rearrange. So what might be better is, well, I mean, this actually is quite straightforward. Times both sides by x plus 2, so we get y x plus 2 is 1. So what I could quite easily do here is just divide both sides by y. So I get x plus 2 equals 1 over y. X is equal to 1 over y minus 2. And you could make this a bit more interesting by combining the two fractions. So if I were combining the two fractions, you would get something along the lines of 1 minus 2y over y. So that also works as well. But either one of these is correct. So then my actual answer is f minus 1 of x is equal to, and again, either one that you want to do. So I like to combine fractions. But yeah, it just says find an expression, so you can use either one of these. So I'm going to write or equals 1 over x minus 2. Both of those are the exact same thing. Okay? So that was nice and easy. And we've done the domain up here already. Perfection. Part C says, we have g of x is equal to x squared minus 5. Solve f g of x is equal to 1/2. So the first thing to do is you're taking g and you're subbing it into x up here. So we have 1 over x squared minus 5, that is the g part, and then add on 2. So that equals 1 over x squared minus 3. And what does that equal to? It equals to 1/2. Okay, interesting. So we're more than likely going to get some kind of quadratic from this. So, I mean, there is actually one thing we can do, is we can cross multiply. So what I mean by that is we're going to times both sides by 2 to to bring the 2 to the top. So actually I'll do it in 2 steps just to make it a bit more simple, but I'm going to show you quickly. And you times both sides by x squared minus 3, you'll get 2 is equal to. So eventually, once you're happy, you can jump straight to this line. And okay, let's have a look. So we're going to add 3 to both sides. We get 5 is equal to x squared. So then x is just equal to the square root of 5. But keep in mind that is a plus or minus value, because we're in A-level maths now, we need to make sure we're taking into account every possibility. So it's either plus or minus, which makes sense. There should always be 2 solutions for a quadratic, unless they're the same. Okie-dokie. One more. So we need to find the range of this, and if you notice, unlike in the first question, they gave me a domain which is any real number, so we have to do completing the square. So like I said earlier, sometimes they're going to force your hand, and they're going to force you to do the actual completing the square method. So f of x is equal to, and if you remember to do completing the square, the formula is like this. So we have x squared plus bx plus c. Then what you'd have is x plus b over 2 squared minus b over 2 squared plus c. Okay, so we have x plus 2 squared minus 2 squared plus 1. So if I were to simplify this, God, I wish I could talk, squared minus 4 plus 1. So we have x plus 2 squared minus 3. So what's the minimum point here? Well, the minimum, all you do is you make the x value negative, so the value inside this bracket, make it the opposite sign, and you just keep the other sign the same. So the smallest y value is -3, which means f of x by definition has to be greater than or equal to -3. That's it. So for the next part, this is something that is extremely confusing for certain pupils. And it's explain why the function f of x does not have an inverse. Now, there are 2 methods for what you want to do here. One is to just remember this one sentence, and you can use it every single time this question comes up, and you're guaranteed to get a mark. Okay? And it's this. Because it is a many-to-one function. That will give you the mark in every single instance of this. Okay? So if you're watching this back on YouTube a bit later, skip ahead to whatever timestamp I've put on screen now. If you don't care, right? If you're just here to get, smash and grab, get the grade, then this is the sentence you need. But if you want the kind of reasoning behind this, I'm going to go through it now. So again, you feel free to skip ahead. If you're watching the live stream live, then you can't skip ahead. You're on this race with me. So many-to-one functions. What that means is many inputs give one output, which if you think about a quadratic makes a lot of sense, right? So if I were to draw this out, we have a function that looks something vaguely similar to this, where this here is -2, -3. And as you may be aware, this is a symmetrical function, right? So equal points on either side of the graph have the same y value. So for example, this could be y equals 1. They're both equal to 1. Here it could be 3. And this could be 3, right? The point is, for any one y value, there's 2 x values. And this should also make sense based on what we had earlier. So when we did the solution here, we got plus or minus value, right? So for one y value, there are 2 x values that give me that value. Obviously, the exception here is the minimum point, right? But the point is if I am working out an x value, I'm going to take a square root at some point, which gives me plus or minus values, which should make sense because it's completely symmetrical. Now, I told you before that if we then take the inverse, this thing swaps. So what that means is it becomes a one-to-many function, which is impossible. So what this means is a single input gives many different outputs. So try and imagine what that will look like. Well, it means for the same x value, you can get any y value. So again, if I were to draw that, I could put in x equals 1, right? And I could get this value and this value. Okay. And essentially what you'd be getting is you'd be getting kind of like a loop like this, which doesn't actually appear in real life. And the reason for that is because, think about it. Imagine if you did a calculation on your calculator, right? Like, for example, when I go on a calculator, I know that if I type in 3 times 6, I get 18. And no matter how many times I press equals, I get 18. With a one-to-many function, I could put in something like this. I could put in a set of numbers, and every time I press equals, I'll get a different answer. Hopefully now you can see why that's a bit weird, because I can do the same mathematical calculation and get different answers every time. So it's pointless, right? It just doesn't make any sense. So hopefully that makes a bit of sense. But now you're probably wondering, if I go back to one of these early questions, I drew what the function is. So the thing is, in your exam, like here, it can ask you to find inverse functions, right? And it can even ask you to sketch inverse functions, but they don't exist, right? Now imagine, like again, this is actually a really, really good example, right? Square root x minus 1. Well, if I take the square root of 4, I get plus or minus 2. So if I do plus or minus 2 minus 1, I'm getting two completely different answers. But how do I know which one to take? It's impossible to distinguish, right? I'd have to make a conscious decision on which one to take. Do I take the positive value or negative value? So it doesn't really work as a mathematical function. You need to have a human being make a logical choice, which, you know, isn't exactly the thing you want to do all the time. Like if you're programming a computer, for example, how is the computer going to decide? Right? You have to put human logic into it. I'm hoping that makes a bit of sense. So it's annoying to me because on the spec it says, teach them that it doesn't exist. But then it also says you need to sketch them and be able to find them, even though they don't exist. But the point they're trying to make is they logically don't make sense and they logically don't exist. Okay, so just as a note to myself, I've stopped the rant about inverse functions of many to one functions. So now we can get going with what we're doing here. Okay, so hopefully you're back. We're going to go straight on to the next one. Sketch the graph of y equals 2x minus 3. If you notice, there's no question number. Why? Because this is also from a past paper. This is from the 2021 paper, I believe. So, sketch a graph of y equals the magnitude of 2x minus 3. So this is another new thing that they add onto the specification for A-level. So, what does this modulus mean? What it means is make positive. Now this doesn't mean swap signs, right? So basically, the modulus of 4 is 4. The modulus of negative 4 is 4. Okay? Anything that's negative, you make positive. If it's already positive, you do nothing about it. So what does this look like in an actual graph? Well, if I were to sketch the graph of 2x minus 3, okay, I would get something along the lines of a value that is going to cross at minus 3 and is going to have quite a steep, quite a steep curve like that, line, right? And I'd want to work out what this x-intercept is. How do I work out the x-intercept? I say y equals 0. So 0 is equal to 2x minus 3. So 3 is equal to 2x. So x is equal to 3 over 2. So this x-coordinate here is 3 over 2. That's it, right? Happy days. Now let's think about what this modulus sign is doing, right? It's saying that I'm making all of this positive. So my y values all become positive. So if I have a look here, y is negative underneath the x-axis. So all of that is magically made positive. So instead of minus 3, I have plus 3. Right? And all of these coordinates will be made positive. So if I match them up, that one, this one here will become up here, this one here, up here. So what it actually looks like is that. Okay? So what you're going to do is basically get rid of this. So your actual solution is that. It should look a bit more even than that, but I'm terrible at drawing, as you are more than well aware by now. But that's all it looks like. It effectively, it's not a reflection. So the way that some people explain it is, it's a reflection in the x-axis. It's not, because this bit stays positive. It's more like it's bouncing off. So if any of you do physics, it's like you're drawing a ray diagram for a reflection, right? So it just bounces off. So imagine it literally hitting, bouncing off somewhere, okay? Or you can be a sane person and just say, okay, all the coordinates are positive for y. So make all y values, make only the y coordinates, right? We still have negative x coordinates, so make y coordinates positive, okay? And it's just like it's bouncing off. Okay. My voice is killing me right now. So what does it mean for actually solving equations though? Well, this is where it gets a bit funky. What you would do here, right, is you should accept that there's two solutions. There's one where it's face value, right? There's one where it's 2x minus 3 is less than 9. However, because I'm making this whole thing positive regardless, it's equally possible for me to have a negative solution. It's just that the solution was made positive, right? So the solution is, the actual answer is positive, but I could have a negative solution that is made positive. It's forced to be positive. So all you do is you stick a negative in front. That's it. You're going to always have double the solutions. So if it's a linear, you're going to have 2. If it's a quadratic, you're going to have 4. Okay? So solving this should be easy as sin right now. So 2x is less than 12, x is less than 6. You're also going to have the exact opposite. So negative 2x plus 3 less than 9. So subtract 3, so you have negative 2x is less than 6. Now, x is greater than minus 3. What happened there? When you remember this, because this is something A-level students forget, because you get taught it in about year 9 or year 8. When you divide or multiply by a negative, you flip the inequality. Flip the direction, or how about this? How about we say change instead? Let's make it a bit nicer. You change the direction of the inequality. Okay. Just the direction, right? So if this was less than equals to, this would still be equals to. It just changes which way around you're facing. Okay. If you don't like that, you could add 2x to both sides and subtract 6. You get the same answer, but why make things longer, right? Okay, so that's how you would do it for something like that. And again, it's the same thing if it has x's on both sides. So again, you're going to have 2x minus 3 is less than x plus 1. Whoops. And you're also going to have this same thing here. And it's, again, like I said, identical. It's completely identical. Right? So solve this, so move this x to the other side, we get x minus 3 less than 1, so x is less than 4. Here, move this 2x to the other side, move the 1 to the other side, we get 2 is less than 3x, so that means x is greater than 2/3. Nice and easy. 2 marks, very snappy, very quick. Okay. So I hope that's starting to make a bit more sense. So realistically, the main challenging ones to rearrange for inverse are the quadratics, and then logarithms and exponentials. But once you've done it a bit, it's quite nice. It's not too bad. So for now, what we're going to do is leave it, and I'll see you in the next one for sure. So.